Yeah,
All right,
recording
recording
started.
has started. Okay, everybody.
And
So thank you so much for joining me today. This is the second session of the revival and renewed series of the Data and AI Architecture Group. I am pleased today to host the legendary Uwe Ricken out of Germany with his material here on the time series data with Microsoft SQL Server. As I mentioned before, when I shared the link on LinkedIn, this is a scenario dealing with time series that everybody that works with SQL Server at some point in time, eventually, somebody will want you to do some time series data with SQL Server. So this is a great bit of knowledge to have in your toolbox. So thank you for joining us today. I will ask if you have any questions. Feel free to put them in the chat, and Uwe will decide when he wants to check out the chat or wait until the end. Keep yourself muted as the presentation goes along. And without further ado, Uwe, the stage is all yours. And thank you again from behalf of the group.
okay, yeah. So my stage here is only a few square meters. I'm in my office in Germany. Hello, everybody. From Germany, I say good evening. So we are a few hours ahead. Yeah, I'm talking about time series in SQL Server. Why do I do that? Because since SQL 2022, we have lots of changes, which made working with time series a little bit easier. And if you want to download the scripts and the demo databases, you just follow this link here. It's t1p.de, and keep in mind that it's case-sensitive timelines. So that is what I want to talk about the next 60 minutes with you, and just a little bit. Oh no, I skipped it. That's a good thing. I skipped the commercial thing about me. I don't like it to say, this is me. Maybe a few of you know me. This is our agenda. So first of all, we need to know what is it when I talk about time series. What does this mean, and what makes time series so special from another database or from other database systems? Um, and most of us, because otherwise we would not have so many people here. The question is, what RDBMS systems, SQL Server, Postgres, MariaDB, and so on, what RDBMS systems are available for the work with time series instead of pure time series databases? And Microsoft did a great job here when it came to SQL 2022. And I want to show you in all the demo. This is a very heavy demo loaded session here. What techniques we can use in Microsoft SQL Server to speed up a little bit the time series queries, because that is normally a really heavy job. Querying time series. That is where we come to what I want to show you here. The question is, what are time series? So time series data is a set of values which is organized in the order of which they occur and arrive for processing. Lots of you, I would say, know that at, for example, Internet of Things, something like that. Or maybe when we are talking about things, what you have all around you, when you're sitting in your office, when you see that, oh, the temperature is very high and suddenly the air conditioning jumps in to cool it a little bit down. That all is working with time series. Time series data are typically written once and rarely, if ever, updated. That is one of the key points what we have with time series. I would say 99.9999% data are just only coming in. So sensors are pushing their data to the web service and they are pushing it into the database, and that's it. Examples of time series are stock prices. For example, telemetry data from sensors. That's a typical thing. That is one big project I was working with that was really, really interesting. Or in your daily business, what you're dealing with when you're coming in, when you're working in IT, performance metrics from all of your servers. And they can be collected into one big database, and all the sensor data, all the performance metrics will have a timestamp in it. When did this occur? So time series are quite often used for historical comparison. So, for example, you've updated your database. Do you see any problems or any performance degradation or maybe improvements? And that is something what you can see very easily when you compare different time intervals. Anomaly detection and alerting. Predictive analytics, quite interesting thing, yeah, but not my job here, to be honest. And reporting, where time is a meaningful access for viewing or analyzing data. And I want to show you a typical thing what maybe a few of you will have. So this year we have decided to have a photovoltaic on our rooftop. And the most interesting thing for me is how much energy does this one produce and how much of this produced energy I'm using for myself and how many I'm pushing to the provider. And here, unfortunately, is in German. I was looking whether I could change it to English, but it was not possible. But that is not the point here. Have a look to the following thing. What you see here is from this day. And here you select the days, you can switch and see how fast it goes. That is the most interesting thing here. And that is something, whenever I'm working in a project, that we get SLOs for that say the data must be written or must be read in less than 1, 2, 3, 4 milliseconds. And now think about that you have in the background billions of rows and you want to have the data in less than a few milliseconds. And here this works, and you can see whenever I switch, oh, come on, so here, this is on the daily basis, this is on the week, this is on the month, and for the full year, you see how quick the data are coming in. And another point, what is interesting, and that deals with time series, is the intervals, the so-called buckets. And when I move over here, you can see that this, when I look at the data for a daily basis, I see that I have 15-minute buckets where we get the information aggregated. When I change over to a week, then I get it in hourly rates. So, and that is something what you can do with time series. The key component is here that we have a very, very fast system, though, that we have good and improved queries and indexes. And this is the point where I jump in how you can work with time series, what tips and tricks I can give you to improve the performance. What makes time series special from other databases? Because normally you would say, come on, it's a relational database. It's the one big table and I push all the data in. But we have tremendous challenges to deal with. And one of the things what I quite often see, and that was a project back 6 years ago, high number of simultaneous transactions. And that is really the biggest challenge when it comes to RDBMS systems, especially, and for example, it doesn't matter whether you have Postgres or you have SQL Server, Oracle, doesn't matter. Because time series are or the performance of time series when it comes to insert in an RDBMS system is, I would say, over 90% architectural design. So that this does not mean, hey, what storage I do have or something, but it's design of tables. And another challenge is the fast-growing data volume. What will you deal with? Maybe a few of you maybe are DBAs and you're suffering from the time series databases you have because your backup will take 6 hours in the night. And then you have the maintenance job and you have the index rebuild, the check DB, and also, and you see that the time window you have for your maintenance will not fit. And that is another challenge what you have with time series. The third point is, from my perspective, it's very simple. It's a same query pattern for finding data. That makes it for developers very, very easy. You can believe me here that when you see, come on, I have this front end, the web interface, and whatever the users are doing, there is basically always the same query in the background. And that is the thing what we need to optimize. But grouping of data volumes, that can be quite hard, because how will you create buckets? And these kind of buckets to create, there was SQL Server coming in with 2022 and made it a lot easier. Mainly query of current values. So that means that we only at the tipping point of the iceberg where we see the data. We are not so much interested in 10-year data, data which were 10 years old. Especially in Germany, maybe not, because we Germans, we love to collect data. So that is something what is typical for Germans. So when it comes to time series databases, we have lots of alternatives for this. In the Azure cloud, we have SQL DB as an RDBMS system or a managed instance, or you can have on-prem. systems. So basically, it's platform as a service, but that is always based on the relational model, and that will have some challenges. Oh, there is one person raising hand. 1 second, please. It's Simon. You have a question? Oh, it's gone. Okay. A very cool, to be honest, a very cool alternative. Must confess, it is a cool alternative, is Postgres. Many of you are working with Postgres, and when you see what Postgres makes possible, what I'm really truly missing in SQL Server, it's truly amazing. But Postgres itself is not dedicated for time series. But what you can do with Postgres is you have so-called extensions. And for time series, you can have the extension called timescale DB. And that's a true heavy hitter. It's amazing what this system can do. So when my customers ask me, hey, what shall I do for this? I would love to prefer going for SQL Server, but when it comes to a huge amount of data, I normally would go in a relational model to Postgres. Azure storage accounts can be used so that you have data lake, for example. Azure Data Explorer is optimized for data series. Of course, I do not know. I'm not so familiar with the cloud stuff, but the king or queen of all time series databases is Influx. This is the most popular database system for time series and OpenTSB. But you see here that, for example, Influx it's great, but it's not really a service, a managed service. You need to have VMs for that in the cloud. And then the question is, yeah, do you want to have it or not? But we are here to talk about the improvements, what Microsoft did inside SQL Server when it was coming to time series. So what techniques do we have in SQL Server? The core concept is that whatever we're doing in SQL Server, we have relational tables. And these relational tables, what can you do to improve this huge amount of data? What you can do is index compression. This is one thing, but an index compression, on the one hand, is good for saving storage, but on the other hand, it will raise a little bit the CPU because data needs to be decompressed when it goes back into memory. Data which are read in a select statement will not be read compressed, but the data will come when they are in the compressed storage, they need to be decompressed when it comes into memory. Another thing what you can do is when you're dealing with a big amount of data is partitioning. Partitioning is cool, by the way. And with partitioning, especially DBAs will have their fun because for one simple reason, if you put every single year on a dedicated partition, or maybe 3 months, quarters, half a year, what else? The good thing is when you know that always data are coming in, the simplest way what you can do is make this partition on a separate file group and make that partition read-only, this file group read-only. And that means for you, you only do a backup once and then never ever again because you have the backup. And the same is with index maintenance. So whenever you run index maintenance, you do not have to do that on read-only file groups, but only on the active part of your database. I saved it. We do say, yeah, one of my customers had a nightly maintenance time around 7 to 9 hours. And with this technique, we reduced it by 1 single hour. That was really amazing. Another technique what you can use for time series is column store index. Column store index will really highly compress data. If you have ever heard, it was in a session from Edward Pollock. He's, for me, the godfather of column store. He knows every single bit of column store. Then you might understand that why is it so good? What SQL Server is doing with column store, we are highly compressing the data, not only on storage, but in memory too. So the memory footprint with column store indexes is really, really tremendous. But column store will have a drawback. One of my friends here said a very simple word, said, there is no lunch for free. And that's the same here. Yeah. So on the one hand, you have an improvement, but you have to pay with a little degradation. Here comes the degradation of column store. Column store index are very, very slow with inserts. I don't want to go too much into detail what a column store or how a column store is dealing with this, but think about this. In a column store index, data are highly compressed. And now think what will happen if SQL Server, or if you insert a new record. What SQL Server then, what we would expect here is, okay, we open it. So it means we decompress it, put the record in, and compress it again. No, that takes too much time. So what SQL Server then do is that SQL Server put the data into a so-called delta store. The delta store is a typical heap or B-tree structure, which is not compressed. And every 2 minutes, there is a so-called tuple mover walking around in the database saying, hey, are there any open delta stores which I can compress? And then it goes into column store. So that means when you have hundreds of millions of inserts into the table at the same time and the tuple mover is going around, then it could be that you're suffering from DML degradation. So you need to be very careful with this. There are some techniques how to improve it. What we are doing is we are using in-memory table. We are collecting the data in memory, and then we are pushing them all 10 minutes back into the column store when we have enough data. But the good thing with column store indexes is that it's highly compressed. So absolutely a game changer here. And the last thing what you can do is you can work with index views. Maybe a few of you have heard about index views, but maybe a few of you are using it for other purposes, however, but index views, I love it when they are used for time series, but index views have so much requirements that sometimes I wish I want to use it, but I can't because the requirements are not fulfilled. I will come to it later when I show you the queries to get that. In SQL Server, the time series are most often used for historical comparison, anomaly detection, and alerting. Time series capabilities in SQL Server were introduced in Azure SQL Edge, Microsoft version of SQL Server for IoT. I do not know whether it's available anymore, and no idea actually. But for me, the good thing was when it came to Microsoft 2022, Microsoft offered a new set of functionality, especially for time series. The first one, and everybody was so happy when it was coming, was the generate series. Maybe a few of you know Isaac Ben-Gan, when he creates his auto numbering, what you can use for your demos, for example. Now it's in SQL Server, it's called generate series. Date bucket, that made me happy. To create buckets for the intervals, for example, every 15 minutes, and so on and so on. One thing I absolutely love is the date trunk function. Really cool thing, and first and last value, but this is not so important. The first three I want to introduce you and to show you how performance improvements were coming into SQL 2022. What was how did we query time series before SQL 2022? And that was especially when it came to the problem solving the bucket solution. So give me every 15 minutes, every 30 minutes, and so on. Or you have a slider where the user can select, give me 5, 10, 15, 30, 45 minutes, and so on. And how could you resolve this before SQL 2022? And here I go with you into the demos. I hope that everybody can read this. Yeah, come on, it's not a it's not a presentation on stage. So I have everything prepared, otherwise it would take way too long. I go into a demo DB that has been created, and here is the first very typical thing. I activate my execution plan. This is the simplest way. Give me, for every year, for every city, the average temperature. Let me show you my data first. This is my weather data. It's only one table. I have the time and the city name, the time zone. That is not so interesting, but here is my temperature. I have one clustered index. Not a good idea, but here in this case, it's better for performance. I have a clustered index here. Let me show you how it is designed. And you can see here that the leading index column, oh, come on, yeah. The leading index column is the city name. And then it comes to the time. What kind of index you choose depends on your requirements, but basically when it comes to a time range where you want to ask data for, in most cases, it is not only for all the sensors in a skyscraper or for all cities, but you normally do a very selective, you are running a very selective query, and I have my leading column on the city name, so that requires me to run a query always against the city name and then to the time. Here is my query, my first query, and what's quite interesting here is, so I have a hot cache, everything is in cache. I run the query, and now the data gets evaluated. Here I have around 26 million rows in it, and you saw that it was taking 7 seconds. Think about your user on your web page. Whenever you run this query, 7 seconds is an absolute nightmare. But here we cannot improve it because we are running a query over all data, and that leads to a clustered index scan. But this index scan is not the problem. The problem in these kind of queries, and whether it's only a few data or it's billions of data, the problem is the aggregation. Why the aggregation? You see here that the data are coming from the cluster index scan, going over into a compute scalar. That is because we want to calculate the year. So we want to extract it. But look to this. Here we have a hash match aggregation. A hash match aggregation will come always into the execution plan whenever we do not have a predictable sort order where the data are coming. But now we would say, hey, stop, stop. We have an index. We have an index on the city name and on time. So what does this mean? It does mean that the data will come by city, and for every city then in the index by time. So we have a sorting here, but it will not be used. The reason is the aggregation or the transformation of the time with a function. So in that moment, the data come unpredictable, and SQL Server must make sure that the data will come in an ordered way. So that is the point here, that we have the hash match aggregation. And now have a look to this. I told you that I have around 26 million rows. Have a look to the memory grant. It was 26 megabytes. Not really much, because I only have a few columns here. I have only 3 columns here. But we need to think big. Whenever it comes to time series, we do not have only one service who is requesting the data, but for example, the photovoltaic, what I have on my rooftop, this producer has billions or millions of customers, and what is when they are all running the query against the stored data. So that means that every single time we want to have the 26 megabytes of RAM. So keep in mind, whenever it comes to an aggregation and a transformation of one of the grouping columns, here, the year, then SQL Server needs to use a hash match because it's unpredictable how the data will come. There is no guarantee that they come sorted by city and then by time, yes, but not by year of time. SQL Server will not consider this. But in 2022 it will. So maybe we can do it like this. It's a little bit tricky, but what you see is here now that I will not do a transformation in the aggregation. So in the output, I move the transformation from the output into a cross apply here. So what does this mean? I want to convince SQL Server, say, hey, the data will not be converted or transformed when it came to the output, but before. And maybe this trick will help here when they run the query. No, it will not work. We will have nearby the same, but because SQL Server is a smart thing, you say, come on, hey, it's exactly the same query. You only move the transformation in a cross apply, but the same as when I do it in the output. So no improvements here. If no pre-ordering is available by an index, then this expensive hash aggregation will be used. And what I want to do here is I want to show you only with this option. Please, 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 please do not use this kind of playing around in production system. That is not a good thing. Let SQL Server basically be the smart guy when it comes to the proper execution plan. But what I will do here is now I say SQL Server, hey, come on, this measure here, I want to force it that it comes ordered to the output. But see this. 6 seconds was it previously. Now I force SQL Server to do that. But you will see now when it is finished that SQL Server has changed the hash aggregation into a stream aggregation. Stream aggregation does mean, okay, SQL Server can trust the data. They were coming in an ordered way and they can directly pass. But have a look to this. Oh my goodness, it was taking 17 seconds. And the problem is, okay, it's well, it's okay. Here's my stream aggregation. That's what I want to have because that's the fastest way to push data to the next operator. But oops, here is a sort operation because we said SQL Server, hey, please sort the data by year because here is the transformation. Then we take the data and we transform them. And now look to this, 26 megabytes it was previously. Look to the memory grant. Why? The reason is very primitive. What SQL Server is doing, we are coming here with 17, oh no, it was not 26 million, 17 million rows. These 17 million rows, SQL Server was in that moment transforming the time or extracting from the time the year. And then we are pushing them into the sort operator, but not only once, but 17 million times. And that made the memory grant exploding. And whether you have SQL 2019 Enterprise Edition, which gives you a so-called memory grant feedback, no chance, because that's the mass of data which will force this huge or will request this huge amount of memory. Here is another thing. I want to have, that's a typical thing, especially when it comes to web sites where you want to see what was in the last 15 minutes. Something like this. How can you achieve this? For example, I want to have the temperature from New York from the last 15 minutes. It is easy normally. Normally, I would say, okay, give me the top 15 rows for New York or order by time descending. But what will happen if you do not know the last, or if you want to have it at a dedicated point? What you need to do is the first point or the first step, what we need to know is what is the last date minus 15 minutes, because that is the stop point from what I go to the end of the index. And this is what I'm using here. I say the time is bigger than the max minus 15 minutes. And it goes very quick. There's absolutely no problem. That goes really cool. Here we have the index seek. This is okay, but have a look to this. It is a very interesting way how SQL Server is accessing the data. It's hitting the primary key 2 times. So it is not going into the index once and say, okay, give me for New York everything what is 15 minutes before the actual time. But what SQL Server is doing is very simple. The first where statement here is when we're hitting the index the first time. But we have here a sub-select. And this sub-select needs to hit the data again. And you see here, we're coming from it's a city name from internal, sorry, that was this one here. And then we are requesting the time, and that is the filter here. This is a range scan, so that's the reason why we get a little bit more data from here. But you see that we are here going now for accessing the index 2 times. And that is a little bit, let's say, not boring, but maybe we could do it a little bit better. Maybe this one here. What I'm doing here is I'm using a CTE. So what I want to see is give me the max data. So what is the last measure? And then I try to run it in a join so that I use the CTE in a join operation, and I ask only for the max for the data which are greater or equal to the evaluated max time minus 15 minutes. Let's do it this way. Maybe it's a little bit better. No, it's exactly the same plan. So we cannot convince SQL Server to do it with access to the table just only once. The reason is very simple. You name it twice. You need 2 different result sets, and that requires 2 times access to the clustered index. This is a typical challenge what we have. Because here, this is, and that is what you say, over 80% of the queries are working like this. You have a start date, you have an end date. And then we want to have for a bucket, the average, the min, the max temperature, what else, but only in this little time range. And this is exactly what I showed you here. Let's go to the daily, and you can see here my bucket size is 15 minutes. It's 6:30, 6:45, and what you see here then is the total of my direct consumption, what the battery was giving to the house, the power we get from the provider, and what we were using in total. But this is a bucket, what we have here. This bucket size is 15 minutes. When I switch over to a week, then my bucket size is 1 hour. So that is dynamically, and this is exactly what people normally would request when it comes to dashboards, that they can use a sliding, say, okay, give me for 5 minutes only, for 15 minutes interval. For example, if you use Redgate SQL Monitor, for example, there is such a feature inside. How can we improve this? Or how could we do this? That was the main point. How could we do this before SQL 2022? And the answer is very simple. We are using a CTE which built up the bucket list. And what I'm doing here is you see that my start date, 27th of April at midnight, and then for 1 hour, I expect 4 values for 0 to 015, 015 to 030, and so on, and so on, and so on. And this is my stop date here. And what I'm doing here is a very simple trick. I take, I hope that everybody of you have heard about reverse querying, reverse CTEs, that I can run in a CTE, a query against the CTE. What I'm doing is I have here my anchor point, and the anchor point is very stupid. I say, give me the start date, and then this is the first column I have, and then give me the end date, which is the start date plus 50 minutes. So now I have two columns, one for the beginning and one for the end. And now I take this here and say, okay, as long as I'm not here at the end date, run this query with the former result plus 15 minutes. And this is how I get my bucket list. Let me show it to you what comes out. So let's start from bucket list. So when I run this query, you see I get here 0, 0, 15, 15 to 30, 30 to 45, and so on. This here is my breakpoint, by the way, the 1 o'clock, but that is okay. Why did it work more? Because this is the stopping operator, but then it came again one. This is a problem in the CTE. I need to clarify exactly, but it's not a problem here. I filter it out later on in the join. So when I now take this bucket list where I have only the time ranges, I can perfectly, really perfectly run it with a join on it and say, give me the average inside this interval. And when I run this query, I get for Austin, by the way, when I would do this for all, that would be very, very that would not be the fastest because then it goes again through 70 million rows. Have a look to what happens. Here is the generation of the CTE. That's okay. But for me, the most important thing is that SQL Server can use the index to seek in it with the given time range. So you see here that SQL Server will use the city name first because that was what I mentioned. I need the first column in the index is the column which reduces the values as much as possible. And then we have a time range on the date, but SQL Server identifies it here, say, okay, give me everything what is greater than, and then the predicate, which is smaller than. That goes very quick, perfect, with the correct index. So this is something where we can play around. So if you say, I want to have it with 30 minutes, you just only change this interval. The bucket list will generate only 2 rows. And then we run it, aggregate it with in between, and that's it. If you want to average for all cities, they must be part of the CTE. Otherwise, you will definitely suffering from performance degradation, because when you only run a query against the start date in this dedicated situation, then SQL Server cannot use the index properly because then you have just only the date in the bucket list. What we must do is we must have the city name in the bucket list too, because we use this here in the query. Otherwise, you will have a disastrous performance in the query. Run this and execute. So it takes a little bit because of Teams and the background noise here in my system, but normally it should be very quick. Okay, I said normally it should be very quick. Oh, here, 11 seconds. Come on, not a really cool performance. Let's see what SQL Server is doing here. And you see that SQL Server here is aggregating the data here, city, that comes from the, from the weather data. So what we are doing here is a horrible thing, because select distinct city name does mean that we go through all the rows. We have nothing one here. Show you later on a little bit a better thing how we can use this. So we scan through everything. We take only the city name out of it. Then we aggregate them, that we come back with the 13 different cities or 10 different cities we have here. And now we can go with these 10 into the sea. So the huge amount of data or a huge amount of time what we've lost here is the full scan. And now think about this. I have only 17 million rows here, but what about if you have 170 million rows? This query will never, ever come back. Shit. So that makes it very, very hard, really very hard to create properly working queries for that because of this huge amount of data. So what will data architects do in that moment? So we are running this query, saying, come on, it's too slow, maybe. So what can we do? And then lots of people coming with the idea of, hey, I've heard about column store index. They are looking so great. Column store to compress the data and so on and so on. They are so happy to use column store index. I have one customer, it was a nightmare. He had on really every table. He had a column store, whether there were 500 rows in or 5 million rows in. So absolutely horrible. However, I have the same data, exactly the same data, but in a schema called column store. Now you need to trust me, it is column store. And I run exactly the same query. Let's see whether it will help in here. And what I want to do here is, because it will never come back, let me show you the actual execute, so the live execution plan. And what we can see here then is the following. You see that the column store index gets used. Super, perfect. This was coming here from the distinct city name. Give me the city name. Okay, that's fantastic. You know, a column store index does not have a dedicated seek predicate. The benefits of a column store index is not seeking in the data, but it's the compression. So whenever you're dealing with column store indexes, column stores can only be scanned, nothing else. However, so you see the query is running, and the reason why it is running is this one here. Whether or not it's not a problem of maybe a miscalculation or misestimation of the data. The key point is that SQL Server wants to go 40 times, because it's a nested loop, 40 times into the column store index scan. And that does mean that we 40 times are completely doing a range scan over all data. And that is the reason why we never come back with a column store. So long story short, a column store, yeah, might help. Absolutely. But a column store, to trust on a column store only when it comes to bucketing is not a good choice. So what can we do with this? There is a trick behind. When we remember the first query, what was the problem? The problem was that SQL Server was going completely through the row-based index to determine the different city names. And for every single city, we wanted to have this time range. If we put only this one, the aggregation of the city names, we take them from the column store index, that goes horrible quick. And then we join it again with the row store index. Maybe that will help. The reason why that might help is a very trivial thing. Think about this. Remember, column store index cannot use the seek technology here. It's a row group elimination, what's going on. But what SQL Server is doing, it is always scanning it. The only index what can use a dedicated seek operation is a row-based index. And now we combine everything. What I do is I want to have, for the evaluation of all city names, the column store. And that goes really, really fast now. You will see it later on. Then we get all city names and we push the city name and the cross apply with the other limitations, start and end date, end time. But now you see here that I'm now using the row-based index. And remember, the first value or the first column in the index was the city name and then the time. Let's see how fast this is. So I'm going for all cities, and I want to have for all cities for 1 hour the last or the average values, and done. So here you can see that we are using the column store index to get the cities. Very, very easy. We get 40 rows back. Till here, everything was fine. That is exactly the same as it was before. But now comes the point. We are now not hitting the column store again, but now we are switching over to the row-based index. And that makes it fast because now we can go directly, look for Austin, look for New York, look for Edinburgh, and go for the dedicated time range. And that makes it so fast here. So long story short, column store is a really cool approach. I love to have column store, absolutely, but for storage optimization. In the query itself, it is not the best deal when it comes to single selections. Query store, the column store index is basically for big data, for data warehouses, for example. So what can we do here? A last option for that is, okay, that fits perfectly. When I create, when it comes to time series, when the customer is suffering from performance degradation because it gets more and more and more data, what I mostly will do is this one here. I go back again to my website here. What do we have here? We have whatever the customer is selecting, always exactly the same queries, because we cannot change it here. The only thing what we change is the parameter of the day, but nothing else. So we are saying give it for this day, or for example, give me for this month, blah, blah, blah. We have a fixed set of queries. And this is in a time series system, basically the core concept. We are not dealing with hundreds of millions of different queries, what they are running with their Power BI or with reporting services or with ad hoc queries. The core concept of time series is that we evaluate the data, but for measuring purposes and normally in very small, tiny intervals. When we know that, what can we do? What we can do is we can compress the data, but not in a way as you have it with column store indexes, because that is not row-based anymore. You have seen the drawbacks of this. But why not using indexed views? The first question is, what is an index view? An index view is nothing else but a select statement you put in a view. So that's what all of us are doing. What's our daily business, right? If you're a developer, that is a daily business. But here comes then the point. I create my view, but unfortunately, index views will have lots of restrictions. One of it is, for example, you cannot use average. No chance. If you want to have an average temperature, for example, you must take the sum, give me the total, and then the number of records, and outside of the view, you calculate it. Let me show you what I mean. So I have here the average temperature in an interval of 5 minutes, for 15 minutes, for 30 minutes, and then I create on this view a clustered index. What happens here? So when you're familiar with Postgres or Oracle, maybe you have heard about materialized views. That's the same here in SQL Server. What we are doing when we create a clustered index on a view, we transform the view, which is normally only a macro, into a real table. So when we run a query against this view, it is the same as when we have a table here. But this table does not have these 17 million rows. It just only has the compressed information by city, by every 30 minutes, the sum and the count. So here I created the index on 5, 15, and 30. And now let's see how this could help. You see here, there comes one point. You see this here? Let me explain it later on. I want to show you. I have an enterprise edition, what I'm running here, but if you're standard edition, you must use that. The very best way to have a tremendously quick result is working with index views. Let me show you what I mean. I want to say exactly the same query. Give me for every city for 1 hour the average. And you see that I'm doing here a calculation. Sum of temperature divided by the number of records. And when I run this execute, it goes incredibly fast. We make a scan on it. That means we go over all, but look to this. The logical reads are way less. Before we had over 70,000 IOs. Now we have just only 10% of it. So as bigger the interval is, so every 5 minutes, it's clear that we then get lots of records, but 15 minutes, or give me with 30 minutes. So whatever I do, whenever the interval is getting higher and higher and higher, the IO will decrease, but that's a natural thing. Coming to a really small drawback, but what you need to take into consideration. Basically, when it comes to so huge amount of data, you would normally run it in an enterprise edition or maybe in the cloud with the managed instance. But if you have an express edition or you have a standard edition, what will SQL Server do? Basically, when you run this not with no expand, SQL Server will, as the name says, expand it and run the real query from behind. So that means it goes directly back to the tables. Only the enterprise edition can fold it and leave it as it is and access this, this view. In standard, you must use it with no expand. Another trick. You remember that we had the big problem that we wanted to gather all the city names, and we tried it with a row base, horrible slow, but then we tried it with a column store index that was really fast. What you can do is when you have fixed names in it, just run it by named attributes. So I'm doing it like this here. So instead of gathering these information from the table, basically, normally I would say, oh, only 5 minutes ago. What you can do is put them in a dedicated table, or like I did here with the values, and that go then incredibly fast. Because now we are doing a seek for every single city, and that's it. 5 minutes to go. Oh, sorry, but I hope that I can give you, that you have 5 more minutes to eat your sandwich or drink your coffee and enjoy it so far, because I would like to show you the functions, what you have in SQL 2022. That was the common way to solve it. We were using common table expressions, which were building the buckets. But now with SQL Server 2022, there were so great features. One of them was the generate series. Generate series, I think all of you who were developers so far had the problem that we quickly needed to have a list from 1 to X. And the generate series is now doing that for you. You give the start and the stop, and you can put a step inside to say only every second. That is very simple. I go, first of all, introduce that, and then I show the demos. Date trunk. Yay. Wow, super. Date trunk is something what I've always wanted to have. Date trunk gives you the possibility to take a date and just only extract a part of the date and generates automatically the rest of the date. For example, if you say, give me only the date part year from today, then SQL Server will return with the 1st of January 2023. So the month and the day gets calculated automatically by the lowest value. That is so cool. And date trunk And the good thing, that will be recognized in ordering groups. You remember that maybe the very, very first example, but I show it later on. And here we have the date bucket function. And the date bucket function, that is what we created manually with the CTEs. Now with date bucket, I can do it only with the function. I say, give me, for example, the minute, 15, depending on the date. And then SQL Server will automatically create the value for the date bucket where it comes to. So here is the idea how it works. When I say, give me from the time, my time column, a bucket of 5 minutes, then SQL Server will take all the rows which fit into a 5-minute bucket and add them to that bucket. And all of them have the same bucket value. And that is very easy and very cool to aggregate them. So how can, before I do that, I want to show it, but unfortunately a little bit quick, but let me show you what I mean. Generate series, love it. So typical thing, you might first of all say, what does that have to do with time series? It has, because we can generate very simple query, the bucket list. Here it is. The generate series, when I say give it from 1 to 100 and the step is 1, then SQL Server gives you 1, 2, 3, 4, and so on. When I do it with the number 5, then it says 0, 5, 10, and so on. So we have 5 interval. And depending on the data type of your interval, it, you see, doesn't work. Why does it not work? Because we have here an integer and here we have a numeric. If you want to have an output in an interval date type, which is different from the start or the end value, then it does not work. So when you want to have that, then you must have all the values in the same with the same data type. In combination with date bucket, that is so cool. Let's say you remember I wanted to have very, very fast last 15 minutes date buckets. Here, I do not touch my table. I generate my series from 0 to 100 in 5-minute intervals. So this is only the counter. And the only thing what I then do is I add the number I generate to my actual date. And the date bucket will then automatically here create every 5 minutes a bucket. The only thing what I then have to do is I need to eliminate it, that I only have the time, for example, but that goes really, really cool. And that helps you. We could take this as a join to the time series then, and then you have automatically the start and stop value. Let me show you last the date trunk. The date trunk, so cool, because I want to get a little bit more into this when I come back to the first query. The date trunk makes it very simple. I run this query and say, give me the year, give me the month, day, hour, minute, and have a look to the output. When I go to the year, SQL Server does not consider anything else. It goes automatically to the 1st of January. And then with the month part, it goes to the 1st of August of our actual year. And when I go to the day and the hour part and so on, and oh, there is a little mistake. There's the minute part only. Just change it. Okay. So that makes date trunk. From this perspective, you might say, no problem. You can do it with format and so on the same way. Yes. But what it do is this. You remember this query here? That was the very, very first query we had. And maybe you remember that there was no prediction in the aggregation, in the transformation of the year. You remember that? That SQL Server needed a hash aggregation to sort the data before it came to the aggregation. So transformation of the measure of the time. And now I do it with a date trunk and have a look to what's going on here. Run this query. I forgot the execution plan. But what comes here? Here is no more hash value. And when you say, come on, a hash value, yeah, no more memory grants. And think big. If you have thousands of people running this query at the same time, SQL Server say, come on, it's okay. I have enough memory of it because you don't request it. So here, if you need but you need the year function for that, but let's see how that will work. Last query. And again, here you see we extracted the year only, but not the whole date. But SQL Server, due to the fact that we are using the date trunk, works as expected. SQL Server will now consider that in the execution plan, and that helps us tremendously to save resources when it comes to execution of queries. So how can you improve your time series? Use proper indexing. Column store indexes might help, but you have seen that it's not the very best choice, especially when it comes to heavy inserts into it. Then forget about column store, do it in a different table. Partitioning can help, but only because of the partition elimination. But your DBA will dance for joy when you use partitioning, because maintenance will definitely be improved. You can use index views for pre-aggregated look of your data, but keep in mind that the index views, and that is the drawback, will always be part of your transaction when you insert data in the table. Because for what? Oracle, when you have an Oracle materialized views, you need to refresh them. They get not automatically updated, but SQL Server will update your index views at the same time when you insert new data. It's a cool thing, but it's an expensive thing. 60 minutes are gone. I see you nearby a point in time ready. I thank you so much for being my guest here for my presentation. I hope you enjoyed what I was showing you, and now I'm open for questions. Thank you very much, Kelly.
Yes, thank you so much for that, Uwe. Well, that's a lot of different ways to do peel the same potato. And lots of I think people really enjoy as well the depth of checking out all the execution plans as well, which I think that's pretty cool. And some of them are kind of unexpected too, where you think it should be fast is not fast, and the other way around too, right?
Yeah. So the good thing is, so whenever you have questions, you can send me an email, and I'm happy to help you here, as long as that you not expect from me a book from hundreds pages to write to you to your common problem or so.
Sounds good. Appreciate it. Thanks everybody for the time, and thank you, Uwe, as well for your time and sharing your knowledge here with the group. And as I mentioned before, I will be uploading as well to the YouTube channel. Thank you, everybody.
Super.
Until next time.
Thank you very much.
Stay
Have a wonderful
safe.
day.
Take care.
Bye-bye.
Bye-bye.